So in the last video, we were talking about the distance formula and the midpoint formula and how to plot points on a graph in the different quadrants. And then in class, I had you sketch some graphs by plotting points and looking for things like x-intercept and y-intercept. For this video, we want to kind of expand on that a little bit, and we want to talk about something really important in math called a function. I'm willing to bet all of you have heard about functions before, but just make sure we're all clear and on the same page. There are different ways to define a function mathematically. The kind of most basic way of saying it is, let's see, for a function, we'll say a rule that associates each element of a set X with one element in a set Y. A rule that associates each element of a set X with one element in a set Y. And the idea is, well, if we think about plotting points in the, like we were doing in the last video, I can just kind of maybe have a bunch of X's and have a bunch of Y's. We can just call these points and say my X values are 1, 2, 3, 4. And if I have the Y values 2, 4, 8, 12, who cares? Does this represent a function? Well, I can certainly consider these points. I can actually just draw parentheses like this. And then I have these points, a rule that associates each element of a set X, those are the elements of X, with one element in a set Y, those are the elements in Y. And it's a function if each X goes to one Y. And in this case, that's clearly true. 1 goes to 2, 2 goes to 4, 3 goes to 8, and 4 goes to 12. But then, just to look at a couple more examples of this, suppose we do this. Suppose I let X be the same 1, 2, 3, 4, but now Y is going to be 0, 0, 0, 0. And again, the question, does that form a function? We said this one did. Is that a function? It's a function if each element of X goes to one element in Y. And in this case, 1 goes to 0, 2 goes to 0, 3 goes to 0, 4 goes to 0. And as far as it goes, according to the definition, each X goes to one Y, which makes that a function. In this case, from a definition perspective, it doesn't matter if all the X's go to the same Y, as long as each X only goes to one Y. So this is also a function. The last one we want to look at. Suppose I have 1, 2, 1, 2. And then for Y I have 0, 4, 8, 16. And again, the same question. I have a set X, I have a set Y. Is that a function? And let's see, to be a function, each element of a set X with one element in a set Y. But the problem here is, I have 1 going to 0, and I have 1 going to 8. There's also a problem with 2. But now, I have 1x, the number 1, going to two different y's, 0 and 8. And by definition, each element of a set x can only go to one y. Here, 1x, the number 1, goes to two different y's, so this isn't a function. This is kind of the point that really matters, understanding the difference. All the x's can go to the same y, and that's fine, that's a function. But 1x can't go to more than one y. And just kind of make sure you understand the difference there. As far as it goes though, when we're actually using these functions, generally we're not just going to have tables of points like that, we're going to have graphs in the plane, like you guys were doing in class the other day. So, just really quickly we get to look at some graphs. Suppose I have a parabola that looks like this. And the question is that a function? And by definition, it's a function if each x goes to one y. And the way to test it is, pick an arbitrary x, say this x right here. I can just go up like this, it hits that y right there. This x goes to one y. And I can do the exact same thing. I can pick a different x over here. it goes to that y. This x over here goes to that y. And clearly, I'm not going to do every single point, but clearly, no matter what x I pick, it will only go to one y. So that's a function. Suppose we have one more. Let's see, what's something relatively easy to draw? How about a circle? Kind of a circle. Do the exact same thing to test if it's a function. Pick an x, say this one. But here, this x goes up to that y, and it goes down to this y. Which means now I have one x going to two different y's. Which is the exact opposite of what a function is. Which means this parabola right here will be a function, the circle won't. As far as it goes, this leads us to a trick that we can actually use to determine if something is a function. It's called the vertical line test. And the idea is, if a vertical line touches your graph more than once, it's not a function. There are different algebraic tests to determine if something is a function, but for the purposes of this class, this is pretty much what we're going to use right here. If a vertical line touches your graph more than once, it's not a function. And all you really have to do is, if I want to know if this graph is a function, vertical lines. And clearly, no matter what vertical line I draw, each vertical line is only going to touch the graph once, so it's a function. Here, I draw a vertical line, it touches the graph more than once, it's not a function. One thing I would point out that is important, technically, if I look at this point right on the edge of the circle, I can draw a vertical line that only touches it once. I can actually do the same thing on this side. But the fact that I can find one vertical line or two vertical lines that only touch the graph once doesn't make it a function. According to the definition, as soon as I can find one vertical line that touches more than once, it fails and it's not a function. So again, make sure you understand the distinction there. Again, like I said, there are different tests to determine if something is a function. For the purposes of this class, all you're going to have to do is graph it and check the vertical line test. Well, let's see. Once we talk about functions, there are kind of different properties we care about. The two main ones that we care about are the domain and the range. As far as it goes, we're going to talk about the domain right now. The range is a graphical thing, and we're going to save that till later on when we do more graphing. So for right now, just forget the range. And we're just going to worry about the domain. And for a